Good day everyone! In this video, we will be solving more problems about the Runge-Kutta fourth order method. So, this video will help you test your knowledge about this topic as we solve more ODEs or ordinary differential equations which have some applications in engineering. So for the first question, determine the values of y using the Runge-Kutta fourth order method when x is greater than or equal to 0 and less than or equal to 5 given the equation dy over dx is equal to x minus 4y over ex plus y, where y0 is equal to 3 with a step size of h is equal to 0.25.
Now we start solving for this question. X is 0 and y is 3 from the given. So for f1, f1 is equals to hf of xy. Ito yung formula na gagamitin natin. I mean yung sabayan. I-insert na natin yung value ng x and y. For f2, we first find the x plus h over 2. Next is y plus f1 over 2. f2 is equals to hf of x plus h over 2 comma y plus f1 over 2. for F3, we have HF of X plus H over 2, comma Y plus F2 over 2. HF for F4, HF of X plus H, comma Y plus 4, 3. To find for the value of Y when X is 0, we use Y of X plus 1 over 6 times F1 plus 2F2 plus 2F3 plus F4. we get 2.30, 98, 94, 58, 3. We will use this value for the next value of x when x is 0.25 and the y yung nakuha natin kanina. Same process lang naman din siya. Kaya yun. And this is the last for the y of 0.5.
Using Runge-Kutta fourth order method, what is the value of y when x is equal to 3 given the ordinary differential equation of y prime is equal to 3x minus y where y 0.6 is equal to 0? Use the step size h is equal to 0.15. So let us now solve the second problem on the Runge-Kutta method. So before we're going to solve the problem, let us first write the given values. So the equation is y prime is equal to 3x minus y, and the initial value given for x is equal to 0.6, and for y is equal to 0. So before we will be able to determine the y sub 1, we need first to determine the k1 and k4. So let us first solve the k1. So for k1, it is the function of x sub I, which is x sub 0 and y sub 0, which is equal to 3 x minus y. So we just need to substitute these values into this equation. So it will become 3 times 0.6 minus 0, and k1 is equal to 1.8. After solving k1, let's now proceed to k2. So k2 is equal to function of x sub 0 plus the step size over 2 and y sub 0 plus the step size h over 2 times the value of k1. So this will become 3 times 0.6 plus 0.15, which is the step size, divided by 2 minus 0 plus 0.15 divided by 2 times the step size, or the k1 rather, which is 1.8, and this one is equal to 1.89. So after solving the k2, let us now solve the k3. So k3 is equal to the function of x sub 0 plus h over 2 comma y sub 0 plus h over 2 times the value of k2. So this will become 3 times 0.6 plus the value of h, which is 0.15 divided by 2 minus 0 plus 0.15 divided by 2 times the value of k2, which is 1.89. So this one is equal to 1.88325. So after that, we can now solve the value of k4, which is equal to the function of x sub o for this part plus h comma y sub o plus h times k3. So this one is equal to 3 times 0.6 plus 0.15 over 2 minus 0 plus 0.15 times the value of K3, this one, which is 1.88325. So the value of K4 is equal to 1.74251. So we now able to determine the value of K1, K2, K3, and K4. So now let us solve for the value of Y in this problem, or in this part of the problem. It should be Y1, where it is equal to Y X sub 0 plus H. The value of this is 0.6 plus the step size, which is equal to 0.15, and this will become Y 0.75. So we can now solve for the value of Y 0.75. So this one is equal to Y sub 0 plus H over 6, K1 plus K2 plus 2K3 plus K4. So this formula is based on the Runge-Kutta fourth order method. So we now have this value. Let us substitute all of the values that we obtained earlier in this formula. So this one will become 0 plus the value of H, which is 0.15, divided by 6 times the value of K1, which is 1.8, plus K2 1.89, 2 times 88325, plus K4, which is this one, 1.74251. So if you input these values on the calculator, the answer for Y1 will be 0.28285. So as you can see here, this value is the function of X, which is equal to 0.75. So we still haven't obtained the value that is required by the problem. So let us continue solving this one. So on this part, the value, or the I, will now become 1. So now the x1 is now equal to x sub 0 plus h, which is 0.6 plus 0.15, which is equal to 0.75. And y1 is what we have obtained. This one is equal to 0.28285. So first, we need to get the values of K1 again using these new values of X and Y. So let us now obtain the value of K1. So for this part, I will now directly substitute all of the values in the equation, because I have already given the equations and their corresponding variables on the first part of this problem. So let us now directly substitute everything. So for K1, 3 times 0.75 minus 0.28285. So this one is equal to 1.96715. So for K2, it will become 3 times 0.75 plus 0.15 over 2 minus the value of y1, which is 0.28285 plus 0.15 divided by 2 times the value of k1, which is 1.96715. So K2 is equal to 1.18384. So for K3, 3 times the quantity of 0.75 plus 0.15 divided by 2 minus 0.28285, which is the value of x1, plus 0.15, which is our step size, divided by 2 times the value of k2, which is 1.18384. So our k3 is equal to 2.103362. So let's proceed to K4, which is equal to 3 times 0.75 plus 0.15 minus the value of y1, which is equal to 0.28285 plus the step size, which is 0.15 times the value of K3, which is 2.103362. So for K4, it is equal to 2.101645. So we are now able to obtain the values of K1, K2, K3, and K4 at x is equal to 0.75 and y is equal to 0.28285. We can now obtain the value of y sub I plus 1, which is equal to y sub 2, where y sub 2 is equal to y times x1 plus the step size, so y 0.75 plus 0.15 is now equal to y 0.9. So we are now solving for the value of y, which is required by the problem. So to solve this one, let us just use the formula that we used earlier in solving the value of y sub 0, but this time we are going to substitute different values of k1, k2, k3, k4, and the y sub 1. So this will become y sub 1 plus h over 6 is k1 plus k2 plus 2k3 plus k4. So y sub 1 is equal to 0.28285 plus the step size of 0.15 divided by 6 times the values of k1, k2, and k3 that we obtain here. So if we're going to input this on the calculator, the value of y sub 2 is 0.54893. So if you are going to look on the choices on the question 2, the correct answer is letter B, which is equal to 0.58, or rather 0.54893. So that's it for question 2. For question 3, using the equation and initial values of x and y at question 2, which are y prime is equal to 3x minus y, x sub 0 is equal to 0.6, and y sub 0 is equal to 0, determine the approximated value of y at x is equal to 9 with step size being doubled, which is h is equal to 0.3. So the question 3 has a similar equation, and some given values are also similar to the question 2. The difference is it has now a bigger step size, which is now equal to 0.3. So let us write first the given. So the equation is equal to y prime is equal to 3x minus 4. The value of x is, the initial value of x is still 0.6, and y at 0.6 is still 0, but this time the step size has been doubled, which is now equal to 0.3. So let us first solve for I is equal to 0. So the first thing that we need to do is solve for k1. So k1 is equal to function of x sub I plus y sub I, which is equal to function of x sub 0, it should be comma, y sub 0. So this will become 3 times 0.6 minus 0 is equal to 1.8. So for k2, the function of x sub 0 plus h over 2 comma y sub 0 plus h over 2 times the value of k1. In the given equation, this will become 3 times 0.6 plus 0.3 divided by 2 minus 0 plus 0.3 divided by 2 times the value of k1, which is 1.8. So this is equal to 1.98. So k3 is similar to the first two questions. Is equal to function of x0 x sub 0 plus h over 2 y sub 0 plus h over 2 times k2, which is equal to 3 times 0.6 plus 0.3 divided by 2 minus 0 plus 0.3 times k2, which is equal to 1.98. So k3 is equal to 1.95 3. So for K4, is equal to the function of x plus h, y sub 0 plus h times k3. So this one is equal to 3 times 0.6 plus 0.3 minus 0 plus 0.3 times the value of K3, which is 1.953. So K4 is equal to 2.1141. So we can now solve for the value of y sub I plus 1, which is equal to y sub 1. Y sub 1 is equal to y x sub 0 plus h. So here we have y 0.6 plus the step size, which is 0.3. So it is equal to y times 0.9. As you can see, we are now solving for the value of y at x is equal to 0.9. So this is what is required by the problem. So it is equal to y sub 0 plus h over 2 times k1 plus k2 plus 2k3 plus k4. So we just need to substitute the values that we have obtained, and y sub 0 is obviously equal to 0 and h is equal to 1 or 0.3. So let us now substitute all of those values. So 0 plus 0.3 divided by 2. So K1 is 1.8, K2 is 1.98, and K3 is 1.953, and K4 is 2.1141. So this one is equal to 0.58901. So based on the choices given on this question, the answer is letter B, which is equal to 0.58901. That's all for question 3. For the engineering problem, we have here a problem which is related to electrical engineering. A voltage source of 8 volts is connected in series with 80 ohm resistor and 2.5 Henry inductor, forming an RL circuit. If the initial current of the circuit is 0, solve for the current at time t is equal to 0.1 second. So I have redrawn the given circuit on the problem. So in this one we have an RL circuit. So in this problem we are going to use the step size of H is equal to 0.05. As we all know, the current of the RL circuit can be solved using an ordinary differential equation. So the ODE for the RC circuit is L di over dt plus Ri is equal to E, where L is the inductance of the RL circuit, the di over dt is the change in current over a given time. The R is the resistance of the resistor in the circuit, the I is the current, and the E is the voltage or the source, or the voltage source in the RL circuit. So let's substitute the values that are given in the circuit. So for L, it is equal to 2.5. So di over dt can be written as I prime. The resistance is equal to 30 ohms, and the voltage source is equal to 8. So you're writing the equation, this will become I 2.5 I prime is equal to 8 minus 30I. So this will become I prime is equal to 3.2 minus 12I. So we can now use this equation using the Runge-Kutta method, which has a step size of h is equal to 0.05, where the initial value of the current at time t, which is equal to 0, is equal to 0. So let us first find the n is equal to 0. On the first problems that we had, it is I, but here, since I is equal to current, we replace it with a different variable, which is n. So k1 is obviously the first value that we are going to solve, so it is equal to the function of t comma I, or t sub 0 I sub 0, which is equal to 3.2 minus 12I. Substitute the value of the initial value of I, which is 0, so it will become 3.2 minus 12 times 0, which is equal to 3.2. So for k2, this is equal to function of t sub 0 plus h over 2, I sub 0 plus h over 2 times k1, which is equal to 3.2 minus 12 times 0 plus the step size, which is equal to 0.05 divided by 2 times the value of k1, which is equal to 3.2. So this one is equal to 2.24. So let's now solve for the value of k3. We all know that k3 is equal to the function of t sub 0 plus h over 2, comma I sub 0 plus h over 2 times the value of k2. So this one will become 3.2 minus 12 times 0 plus 0.05 divided by 2 times the value of k2, which is 2.24. So the k3 is equal to 2.528. So after solving for k3, let's now proceed to k4. So k4 is equal to the function of t plus the step size h, y sub 0 plus h times k3. So this one is 3.2 minus 12, 0 plus 0.05 divided 2 times k3, which is equal to 2.528. So this one is equal to 1.6832. So we can now solve for the value of I sub n plus 1. So this one is equal to I sub 1. So I sub 1 is equal to t plus step size h. So this will become I 0 plus 0.05. So this will become I 0.5. So we are now solving for the value of the current at time t, which is equal to 0.5. So this is equal to h, which is 0.05 divided by 6. I'm sorry. So before this, we are going to add the initial value of what I sub 0, or I sub 0, which is equal to 0. So I sub 1 is equal to 0 plus 0.05 over 6 times the value of K1, which is 3.2, K2, which is 2.24, plus 2 times K3, plus K4, which is 1.6832. So the value of I sub 1, or the current of the given circuit at t is equal to 0.5 is equal to 0.12016. So we still haven't obtained the required time, or the required value of the current at time t is equal to 0.1. So in this part, we are going to use the value of n, which is equal to 1. So we already knew the value of the equations needed to solve for K1, K2, K3, K4 on the first part of the problem where n is equal to 1. So in this part, we are now just going to directly substitute all of the given values in those equations. But let us first remember that the I1 is equal to 0.12016, and the t that will be used in this problem is equal to 0.15. So, or 0.5 rather, sorry. So let's now solve for K1. As what I've said, I will be now directly substituting all the values in the given equation. So 3.2 minus 12 times 0.12016, which is the value of I sub 1. So this one is equal to 1.75808. So K2 is equal to 3.2 minus 12 times 0.12016 plus 0.05 divided by 2 times the value of K1, which is 1.75808. So this one is equal to 1.230656. So K3 is equal to 3.2 minus 12 times the quantity of 0.12016 plus 0.05 divided by 2 times K2, which is 1.230656. So K3 is equal to 1.388883. So let's now solve for K4. So it's equal to 3.2 minus 12 times 0.12016 plus the step size, which is equal to 0.05 times the value of K3, which is 1.388883. So this one is equal to 0.92475. So we are now going to obtain I sub 1 plus 1 which is equal to I sub 2. So this one is equal to y, or I, in which t is equal to 0.1. So we are now solving for the current of the RL circuit in which t is equal to 0.1. It is now the value that is required by the problem. So this one is equal to y sub 1, or I sub 1, which is equal to 0.12016 plus the step size, which is 0.05 divided by 2, or divided by 6 here in this formula, times K1, which is 1.75808 plus K2, which is 1.230656 plus 2 times the value of K3, which is 1.388883 plus the value of K4, which is equal to 0.92475. So the value of the current at T is equal to 0.1 is equal to 0.186176. So it is a current, so the unit for this value is ampere. So in this problem, the current of the RL circuit in which T is equal to 0.1 is 0.186176 amperes. So that's all for the engineering problem. Thank you for listening, or thank you for watching.